Okay, so am I audible? I think so. So, good evening, everyone. Sorry, I couldn't take the class last week. So, last week, we had done these some trigonometry and solution of triangles. So, let's copy them.
Sir, will you discuss these questions?
Yeah, yes, I will. Okay, so what's the first one? Yeah, the first one is easy. So x cubed minus 11x squared plus 38x minus 40. This is the cubic equation. The sides are the roots. So we have to find cos a by a plus cos b by b plus cos c by c. That's so b square plus c square minus a square by 2abc, a square plus c square minus b squared, and a square plus b square minus c squared. So one set of squares cancels out. So a square plus b square plus c squared. So now from the quadratic we have sum over ai is 11. Product over ai is 40, and sum taken two at a time is 38. So this is 29 by 40. So 29 by 80. So this is 38. So this is 76. And this is 45. So it's 9 by 60. Okay, so in center and circumcenter. somewhere around here we have the circumcenter. This length is r, and in center I. So our aim is to kind of work with this triangle OIB. So in triangle OIB, uh, we will find this and this these two sides and try to find this side from this angle and the adjacent sides. So now what is this angle? So angle OBI is BI is already the angle bisector. So this is B by 2 and this is B by 2. So now first, what's the angle ABO? So so this is a circumcenter. So this is the angle at the center. Uh, so this is twice of C, and since this is a like an isosceles triangle, so this is C and this is C. So this is 90 degrees, so this is C dash. So this is 90 minus, I mean, yeah, we have pi by 2 minus C by pi by 2 minus C. So angle ABI equal to B by 2. Therefore, OBI is ABI minus OB, sorry, ABO. So it's so P plus C minus 180 plus C by 2. This is A. So A plus C by 2. No, sorry, this is minus A. So it's C minus A by 2. Okay. So angle OBI. So we got hold of one of the angles. Now OB is R. That's anything like B by cos sine B. Sorry. And lastly, we have BI. So this is smaller than in radius. And so this is R by sine B by 2. And R can be replaced with that 4R sine A by 2 sine B by 2 sine C by 2. So now we are in a position to apply cosine rule. So from cosine rule, we have OI square equals OB square plus BI square minus twice OB into BI times cos of that angle OBI. So we got OI square equals OB is R, so 16R squared sine A by 2 sine C by 2 minus twice R squared or 8 times sine A by 2 sine C by 2 and cos of C minus A by 2. Taking R square common, then sine A by 2 C by 2 common. So 16 minus, just a minute. We can even take the 8 common. So twice sine A by 2, sorry, Mr. Squared, sine C by 2 and minus cos C minus A by 2. This is equal to R square plus 8 sine A by 2 sine C by 2. And cos C minus A by 2 is sine, okay, so it's sine C by 2 sine C plus A by, this is B by 2, and so we have just a minute, sorry. So it's minus of sine A by 2 sine C by 2 cy2 twice here and one gone. So sine a/2 cy2 minus cos cy2 cos a/2. So this is again cos a plus cy2 minus of that. So what is a plus c/2? It's 90 minus b/2. So sine a/2 b/2 and c/2. So that's our OI squared, which gives OI to be so we needed a different form this time. So yeah, we can use that same fact again, that small r is 4 capital R times twice of r by r. So it's r square minus 2rr. So now orthocenter. So circumcenter is somewhere over here. Orthocenter is way up here. So we'll again try to evoke the same technique of using cosine rule in triangle OBH. So this is same as R. This angle is C, this angle is C. Hence this is C dash. And this is 90, so this is C dash. So angle OBH OBH is equal to B minus twice angle C dash. So it's B minus twice 90 minus C. So it's C minus C. Previously it was C minus A, why it was now C minus A. Yes. And BH, to find BH, um, we can use this triangle, I guess. So this is C. This is a from triangle AB. So triangle ABD, which is a right triangle. So it's C cos B. Right, it's C cos B. Therefore, BH is C cos B times, this is again C. So just a minute. So if I want to find BH, we know this angle C on this side. So that is sine, right? So BH sine C equals to BD. So BH is BD by sine C. BD is C cos B by sine C, that is R cos B. So R cos B. And OB is R. Therefore, in triangle OBH, from cosine rule, OH square is OB square plus HB square minus twice OBHB cos C minus A. R squared plus R square cos square B minus twice R square cos B cos C minus A. Again taking R square common and then cos B common. It's cos B minus cos C minus A.
Sir, C cos B by sin C equals to R cos B or 2R cos B?
Okay, yeah, sorry. So it's 2r. I missed it. 2. So here it will be 4. Here also 4. So 4 cos b times. Now this is, so we can write cos b as c plus a, since it's 90 minus c plus, it's 90 minus b, right? So it's c minus a. Twice c and a. So r squared times 1 plus 8 cos a cos b cos c. That's all its squares. So is, this was the form we needed, right? Okay. So now Excentres. It is a better copy paste that image. So now, so we need to show R1, which is this one, is delta by s minus a. So we will try to find delta in terms of R1. So delta is the area of triangle ABC, which is equal to um, area of triangle I1AC plus area triangle I1BC, sorry, I1AB minus area of triangle I1BC. What is I1AC? So we can draw a perpendicular. This is R1. And this base is already AC is B. So half times base times height. Similarly, R1 C, so half times CR1 minus half times, this is A times R1. So that's B plus C minus A. So S minus 2A. No, sorry, S minus A. What am I writing? It's 2S minus 2A. Similarly, we can prove for the other two excentres. So now what? Just a minute.
Sir,
Yeah, sorry. Someone wanted to say something?
sir,
Hello?
sir, I was saying that, sir, sir, can you post the solutions in the group of means of the problem from the next day so that means we can discuss more problems in this time means we can read it out the solutions.
Yeah, I will post the notes after the class. I do every week, right? So it is
No,
part
sir.
of the notes.
Like before, we are discussing this right now, na? Like
Okay,
you can
okay.
post the solutions one day before the class, and then if anybody has doubt, then he or she can ask in the class itself.
Yes,
This
sir.
way, we can save time.
Yes, sir. And
Okay,
we could
okay
do
then.
more problems here.
Yeah, okay then. I will do that from next week. Okay.
Thank you, sir.
Yes, sir.
So now, what's left? We have something called MN theorem. Yeah, Apollonius is important. So Apollonius is basically a generalization of Stewart's. Okay, so the following relation holds. So just a minute. PA times BC squared plus PB times AC squared plus BC times AB squared equal to so like PA times BC squared plus BC times AB squared equal to AC times so like if you consider this is the median as of is B is the midpoint, then this should be same as the Polonius one. So it's PA square plus BC square equals to twice of PB squared plus AB squared. That's the Polonius. Just check if this is coming. So PA times BC squared. So from here it's you can take AB common. So it's twice. Sorry. PA plus BC. AC is again so AB BCC is so AB squared times twice AB squared. Okay, so AB cube and PB squared times AC squared. Four times. So this is also four times. Okay, I guess I messed the squares with the. So these guys are the ones to be squared. Sorry. This is PB. And this is PC. Now this should be okay. So I didn't change the right hand side. So now it will be PA squared plus PC squared times AB equals AC, that's twice AB. So these two will cancel. PB squared plus BC and AB are the same. So AB squared. Okay, verified. So Now, proof, right? The proof basically involves dropping a perpendicular and then considering all those triangles and using Pythagoras and Heron's formula over and over again. So I don't think it's that important or insightful. So let us skip the proof for now. Okay, let's solve some problems. So show that uh, okay. So sum over 1 by Ri is 2 by R. So the sum of the reciprocal of, like the harmonic mean of the excentres is the incenter. Sorry, of the x radii is the in radii. So this is the harmonic mean. So which implies 2 by 1 by R1 plus 1 by R2 plus 1 by R3 equals to R. So how to prove it?
We can use that formula that you wrote above, like R1 equal to delta by S minus A.
Yeah, so using that we have the LHS delta by S minus A S minus, sorry, I'm writing it upside down. So it's 3S minus 2S. So it's S my delta.
I think it should be 1 by R on the right hand side.
Yes, yes.
Sure. Okay. So it's not that beautiful like I thought it was. Harmonic mean. Okay, half of that. So then we don't have the 2 and now it's delta by S, that's R. Okay, nice. Now the next one is R1 by R minus R1. cyclic products. This is also just put and solve kind of problem. I hope so. Like, so this is delta by s minus a, delta by s minus, so not s minus. Sorry. So multiplying with s into s minus a, we have s minus a, s. Why is a negative sign coming here? So s minus a was smaller, 1 by s minus a was larger. Okay, so negative sign is not a surprise. So if the left hand side is negative, how come the right hand side is positive? Okay, actually these are not the in radius and circum and x radii. They have a different construction. I didn't read the whole problem. So the problem says you have a triangle, then you have the in circle, and then we have the perpendicular dropped from the in radius, sorry, in center. And then another circle. this circle has radius r2. The first one had r1. No, sorry. First one had r. Okay, okay. Now the similar construction is done in every sector. This is r1. This is r3. So now, we have to find new expressions for these ri's. So how to solve it? So, if we talk about this triangle, yeah, okay. So these 3 points, call this C2, C3, C1. So now observe that B, C2, and I are collinear. This is because everything is symmetrical here, like the this is so this is BD is equal to BE, and all these perpendiculars are R. So BDI is congruent to BEI, and similarly in this circle, the smaller one, since the point of tangency passes through the centers of both the circles, C2 and I, and this point, can we name it P2? So P2, C2, and I are congruent, are collinear, and uh, why are those 2 points? So and lastly, in this small triangle, okay, so let me name them. It's getting messy. Okay, so now from that we have in triangle C2I and this contact point, calling it N2. C2I N2. This triangle is a right triangle, and angle IC2N2 is equal to 90 minus angle C2I N2. And C2I N2, oh yeah, these two are these two are parallel, since both of them are perpendicular onto the same line ID. So now we have this angle and this angle same. Okay, then directly say these two are same. This is Vy2, since center is the intersection of the internal angle bisectors. Okay, so it's so now uh, what can we say about, okay, so what is C2I? So we know C2I is R minus R1, R2, sorry. C2I is R minus R2. And that's, no, and we also know C2N2 is R2. We don't know the third side. Okay. So using these two sides, we know cos B/2 is R minus R2 by R2. Now so we got this term. So it's obvious that we can get the rest of the other terms as E/2 is R1 minus R1 and C/2, sorry, is R minus R3 by R3. So multiplying cyclic product over Ri by R minus Ri. It's basically
Sir, how did we prove that B, C2 and I are collinear?
because you see this angle, just a minute, what is this? We have so one of the lines is the line defined by P2, C2 and I. They are collinear due to tangency. The other line is defined by I and B, right? So this perpendicular is the same one. And that perpendicular is also the same one. This is E. Sorry, not D. This is D. This is E. And we know that this triangle, these two triangles are congruent. So these triangles are same. And again, in this case also, I mean, this line, the IC2 is also the angle bisector of angle DIE. And similarly, IB is also the angle bisector by definition of, no, not by definition, yeah, not by definition, by similar congruencies of DIE is bisected by both IC2 and IB. Hence, C2 and B are collinear. I mean, IC2 and B are collinear. Any issues now?
No, sir.
Sir, could you please show the last line for once? Done.
Just a fact. I don't know if you know that. So, fact is any triangle ABC. If this is an obtuse angle triangle, then the orthocenter will lie somewhere outside. The picture is probably too rough.
Sir, and for a right angle triangle, it will lie on the vertex which contains the right angle, right?
Yeah, uh, that's not what I was trying to point out. I was trying to point out that if you try to find uh, the orthocenter of the triangle BHC instead of triangle ABC, whose orthocenter is H, this triangle will have the orthocenter of A. And similarly, if we try to find out the orthocenter of ABH, it will have C as the orthocenter. Like you get it. So
Yeah, because A lies on the perpendicular bisectors itself.
yeah, and sorry, no, I missed the B. This actually happens for any triangle, not for only obtuse angle triangles. And also, if you reflect the orthocenter, suppose this is the orthocenter. If you reflect the orthocenter with respect to the base BC of the triangle, then it will lie, the reflection point will lie on the circumcircle. Similarly for any side. So let's prove it then. Actually, all these small facts will be necessary to prove that Euler line property, that the distance between the centroid, so you can remember it in this way. So the Euler line is the line defined by the centroid and the orthocenter. So the circumcenter also lies on the same line. So circumcenter, orthocenter, and centroid are collinear, and the centroid intersects the line defined by H and O in the ratio of, sorry, not equal. Two is to one. Okay, so now let's prove it. So this is H. Suppose this is O. Not here. Here. This is G. So first we will prove this line. This line is collinear. Okay, so
Do we have to prove that reflection property you stated earlier, or we can use it as a fact?
yeah, we will prove everything. Just a minute. First, first I have to prove they are collinear, right? Okay. First I have to prove they are collinear. I think I have to draw the circle. So this is the altitude, and this is the perpendicular. So both of them are perpendicular. So that shows they are parallel. The other thing is this construction is wrong. So call this point P. This is just a diameter.
So what do the two arrows imply?
Nothing for now, but they usually imply parallelism. Like I thought I would
So
construct.
that's what is making me confused.
Yeah. Okay. So why does it pass from A bar? So now this is the diameter. So uh, this is angle. This angle is 90 degree, right? ABP. Since AP is a diameter, angle ABP equals angle ACP equals 5 by 2. And this BE, this BE is also an altitude, so it's perpendicular onto the same line AC. Since BE equal to AC, so this proves BE and PC are parallel. So, and similarly, uh, these two set off. And this is also perpendicular since which is perpendicular. No, they are not perpendicular. Okay, nothing similar. So CF is perpendicular to AB, which is in turn perpendicular to BP. Therefore, CF is parallel to BP, and CF is same as CH. So CH parallel to BP and BH parallel to PC. Therefore, quadrilateral BHCP is a parallelogram, which implies which implies that A bar lies on the point of intersection of BP and PH, which are the diagonals of BHCP. So we proved P, A bar, and H are collinear. Like this is same thing.
We can also say that PA is equal to AH. PA bar is equal to A bar H, right?
Yeah, they are bisected. Same as already we know by construction, B A bar is A bar C. So now we are one step ahead. So now we can say we can talk about the triangle PAH. So in PAH, we have, so like obviously OA bar is parallel to, so OA bar perpendicular to BC perpendicular to AD. So OA bar is parallel to AD. So implies OA bar is parallel to AD, same as HD or AH, sorry. So now in triangle PAH, PAH, OA bar is parallel to AH, and this is the midpoint. A bar is the midpoint, and A bar is the midpoint of PH. Therefore, you can use the midpoint theorem. A bar by AH, so OA bar by AH is equal to PH by, sorry, what is this? PA bar. PA bar by PH. It's half. So OA bar is half of AH. Okay. So it's not looking that good, but this is twice of this.
Sir, could you explain like what you did in the end?
I proved this thing is half of this thing. OA bar is half of AH from the triangle PAH, from this thin triangle PAH.
Oh, okay, okay.
I proved the part of the heights are kind of.
Right, I got it.
So now I have to show the, yeah, so basically this line, I will show that intersection point is G. How to show that's G? What is the definition of a centroid? Yeah, it's the intersection point of the the medians, right? So already A bar is one of the median.
If we can prove that the AG by GA bar is equal to 2, then like we
Oh yeah,
can
yeah, we can use
determine.
that. Yeah, we already know. I don't know if you know or not. So mm, midpoint, and midpoint. So medians intersect themselves at the centroid, and this the bice. I mean, they intersect in a ratio of 2:1. This can be easily proved by this construction of a, yeah, protruding parallelogram. And sorry, I made the wrong. Uh, what is the construction? Is it the parallelogram first, or uh, this bisect? If I draw it, if I just extend it, whatever. Basically, we will be able to prove this thing, and then just say this is 2:1. So here we will try to use the same fact by showing uh, which one is 2. This is 2, right? This is 2. This is 1. So already these two triangles are similar since they're bounded by the same set of parallel lines, OA bar and AH. They already have an angle sharing, so this angle are already same by. So let me draw them once more. Yeah, I have already drawn them once more here. Okay, so these two angles are same, and these two angles are same, so they are similar. So triangle AGH. It's not G, okay, this is G bar. AG bar H is similar to triangle OA bar G bar. This is I'm calling it G bar since we don't yet know if it's a centroid or not. So this is by construction the intersection point of OH and AH bar. So now from similarity we know this is what was this 1:2. So this is 1:2. AH by OA bar equals to 2 by 1 equals to AG bar. Sorry, AG bar by G bar A equals to OG bar by G bar G bar H, which implies AG bar is twice of G bar A. So G is the centroid, therefore G bar is the centroid of ABC
So
segment.
shouldn't it be A G dash equals to 2 G dash A dash?
Yeah, sorry. I didn't write a dash, right? I was saying the dash. 2 G dash, 1 G dash. Yeah, G dash A dash. So that's a centroid since, okay. Yeah. And along with that, we also showed that the Euler line property that OG dash by G dash H is 1:2. That completes the proof. Next, we have the 9-point theorem and 8-point theorem. They are not that useful as. Just a minute. Now let's see how to prove the reflection point lies on the circumcircle. So by construction, this is perpendicular and these two are bisected by the side BC. So this angle and this angle are the same. This is perpendicular, so mm, so this angle is C. This is C dash, and then this small right angle triangle. This is C. So both angle, so angle BHD equals to angle BH bar D equals to C. Yeah, and this is also C. So that implies H dash is on circle, right? Yeah, as they are the same angles extend the chord BA. What do you say? Extends an angle of C at the circumference at both point C and H, and point H bar. H bar lies on circumcircle. So what's there in tomato? Let's see. So let's look at problem 119. It's- So it says, so this says short answer type. The adjoining figure CZ is perpendicular to AZ and sorry, perpendicular to XY, and the ratio of the lengths AZ to ZB is half. So CZ is perpendicular to XY, okay, and the ratio of the lengths AZ to ZB, AZ and ZB, this ratio is 1:2, and the angle ACX is alpha. This is called alpha. This is called beta. Find the expression for the angle AZC. So we have to find AZC, this string, in terms of alpha and beta. Okay. So any idea how to proceed? I know a ratio.
Extend CA.
Okay. So you're trying to make it a median.
Yes. So
Right.
Z
Then
is a centroid.
sorry, then I extended it too much. How to undo? So I've extended CA to a point A bar, right? So that CA is equal to A bar. So extend
Which angle do we have to find?
angle AZC.
The angle ACZ is also alpha,
Yeah, ACZ is alpha and BCY is beta.
and ACX is also alpha.
No. ACZ is not alpha, it's alpha dash. Sorry. I mean, it's 90 minus alpha. That was what I was trying to. So centroid. How will that help us out? This is not perpendicular, right? So
The line CZ is perpendicular to XY, right?
Yeah. So we know only one angle in that triangle, ACZ. So ACZ is 90 minus alpha. Similarly, ZCB is 90 minus alpha, sorry, beta. Can we apply Menelaus, like this by this? No, this by this, this by this. We already know this is a median. So let's call the angle that we need to find something like theta. So let AZC be theta. So then angle CAZ, sorry, yeah, CAZ is 180 minus theta minus 90 minus alpha. So 90 minus theta minus, sorry, plus alpha. If we try to apply sine rule in AZC, let's see what we get. So ZC by sine A, AZ by sine C, sine Z, AC by sine Z. ZC is ZC. Sine A is sine 90 minus theta, theta minus alpha. So this is cos theta minus alpha. 90 minus alpha, so cos C. This is sine theta. Similarly, we can do the same thing in triangle ZCB, I guess. So ZCB so this point was called B. So ZC by sine B, BC by sine Z, and BZ by sine C. What is B? So angle B is so B plus A is alpha plus beta. Mm, so this is alpha. So this is the external angle. So B plus A is alpha plus beta. So B is alpha plus beta minus angle A. Angle A is 90 minus theta minus theta plus alpha. Alpha plus beta 90 minus alpha. So it's minus of 90 minus theta minus theta plus beta, right? So sine of minus something, so it's minus of cos of theta plus beta. Sine z, sine z is again sine theta. Sine c, that's sine beta, sorry, cos beta. This was cos alpha, this is cos beta. What do I need to find? I need to find theta, right? Theta. We know AZ by BZ is half. AZ and BZ. So let's divide them. Yeah, we can use this and so dividing. So ZC by cos theta minus alpha times cos alpha by ZC by minus cos theta plus beta. So this is AZ by BZ. So this implies cos beta by twice cos alpha equal to minus cos so it's sin theta sin beta cos theta cos beta cos theta cos alpha minus sin theta sin alpha. You have to solve for theta. It's a single variable and a single equation, so we will hopefully be able to solve it out. Let's divide by cos theta now. So tan theta cos beta cos alpha tan theta sin alpha. Let's call it gamma, left hand side. So we have let's not call things cos v cos beta cos alpha tan theta cos beta sin alpha cos alpha tan theta sin beta minus 2 cos alpha cos beta. Collecting the tan theta terms, tan theta times minus cos beta sin alpha minus 2 cos alpha sin beta cos alpha cos beta minus, oh yeah, that's 3 times. So tan theta equals to minus 3 cos alpha cos beta times yeah, so it's theta is tan inverse of cos alpha cos beta by twice cos alpha sin beta plus cos beta sin alpha. Okay. And as for homeworks, assignment, I will try to post the solutions before next week's class. Mm, so this is 116 in triangle ABC. Show that sine A plus sine B minus cos C is less than or equal to 3 by 2. Hmm. Number two is show that area of triangle I1, I2, I3. These are the three incenters of the these are the three excenters of triangle ABC. It's equal to ABC by 2R. This is the incenter in radii. The last one is
Sir, could you please repeat what are I1, I2, I3?
here. These are
Okay, sir.
the
Okay, sir.
excenters. Okay, I guess I should paste a copy of that image here. The last one are some sets of inequalities like show that sin A by 2 sin B by sin C by 2 is less than or equal to 1 by 8. And the last one is given R1 equals to R2 plus R3 plus R, show that triangle ABC is right triangle. That's all for this week.
R1, R2, R3 are respective excenters. X
Yes.
radius.
Yeah, X radii. Okay then. Goodbye. I will post the solutions before next week.